Hello everyone, dear listeners. This presentation deals with the geolocation anomalies detection on MeghaTropiques satellite, an aging mission which has just celebrated its 9th birthday. This article is a result of a cooperation, and I would like to thank all my co-authors from CNES, CELAD and MeghaTropiques. MeghaTropiques is a spatial joint collaboration between India, the ISRO, and France, the CNES. The satellite, launched in 2011 in October, is the space component of a scientific mission which main goal is to study climate and atmosphere. It has a very specific and original circular orbit between the tropics to study water cycle and energetic exchanges in the intertropical convergence zone, thanks to its two payloads, SAPHIR, a microwave sounder, and SCARAB, an optical radiometer. But at the end of 2018, after 7 years in orbit, a major anomaly occurred on board. After many investigations on ISRO side and a new acquisition sequence on board, a lighter data flow has been maintained, around 30% of the level 1 products, but with random quality degradation, especially in geolocation performance. You've got here an example of a SAPHIR product. You've got here the coast of Africa, and you can see where in the product the coast is located. So this means there's a geolocation shift here. Two methods have been implemented to detect this kind of problem, which is the key subject on MeghaTropiques mission. The first method used the MeghaTropiques cycle of 97 orbits and the ground track modelization, which is derived from the circular orbit equation. You can here see this modelization. The goal is to compare a reliable product which is correctly geolocated, with a wrong product, a shifted product, but in the same orbit in the cycle. The result is here in the figure. In blue, you have the accuracy of the model, which is enough for the geolocation errors we are looking for. But in orange, you have the comparison, the result of a comparison between a good product and a shifted product. And this amplitude of the orange curve is the same as the accuracy of the model and cannot be associated with the type of errors we are looking for. So these, as a consequence, this method cannot be used to detect this kind of anomaly. The problem is part of the context. So a second method has been analyzed, resulting from an original approach. It uses the MeghaTropiques SAPHIR assimilation output as a reference to detect spurious data. Indeed, SAPHIR near real-time level 1 products are operationally assimilated in MeghaTropiques weather prediction models, and the output data, which is resulting from this process, and especially the standard deviations of differences between observation and model, can be used to provide feedbacks on SAPHIR data quality itself. In particular, by analyzing the spikes in this time series, we have noticed there's a perfect correlation with the geolocation problems. Here you get a spike, and this spike corresponds to some data, some times data, some acquisitions which are badly geolocated. And when you are in the average value of this time series, you can match perfectly with products which are well geolocated. So these promising results should enable to detect a posteriori badly geolocated product, and the goal is, of course, to provide final users with precious information on the MeghaTropiques data quality. The next step now is to implement it operationally this kind of checking in order to provide to the users the quality information updated for this mission. Thank you very much for your attention.